Today we're going to take a look at work problems. Work problems are word problems that involve rational equations. Before we can do such a problem, we must review a few fundamental ideas that are understood behind any work problem. So let's take a look at the do now. Suppose Katya can finish her math homework in 30 minutes. What part of the homework will Katya complete in 1 minute, 20 minutes, 30 minutes, and X minutes? And we're going to represent the part of the homework completed as a fraction. So take a minute, copy this down, and complete the chart. Okay, so after 1 minute, Katya would have completed 1/30 of her homework. After 20 minutes, Katya would have completed 20/30 or 2/3 of her homework. After 30 minutes, Katya will have completed her homework, but as a fraction, we express that as 30/30, which is 1. In general, if Katya works X minutes on her homework, where X is the variable, the numbers that change or vary in time, we could represent the fractional part of the homework completed as X/30. And this is a very important idea behind any work problem. So let's just make a little list here of our ideas. Very fundamental but important. Okay, the part of the job completed, the part of the job or the work completed in 1 unit of time is called the rate of work. So in this problem, Katya's rate is 1/30. Oh wait, I misspelled that. Katya's Okay, so for rate, the numerator is always 1, and the denominator represents how long it takes her to finish the work. Okay, and in the do now, if we wanted a formula for the part of the work completed, notice that we have to take Katya's rate. So I'll just write down rate. And to get the 20/30 and 30/30, what did we do with the time and the rate? We multiplied the time, which is a number. So let's say she worked for X minutes, so that the part of the work completed was X times 1/30 or X/30, if X represents any number of minutes between 0 and 30. So we have this important formula. The part of the work completed is equal to the time of the work times the person's rate. And remember, rate is always 1 over a number. So this part is our fraction. The rate is our fraction. The time is a number. Okay, so can you think of another word problem that uses a similar formula? Yes, motion problems, where time times rate was distance. Okay, now let's take a look at the next situation. Suppose you take Sadie her math homework in
in
40
40
minutes.
minutes.
So, what is
Sadie's
Sadie's rate?
rate?
Okay. What part of the homework will she have completed in 20 minutes? Okay, so let's look at that. So Sadie's rate would be 1 over 40. And what part of the homework will Sadie complete in 20 minutes? 20 over 40. Or one half of the homework. Now, suppose Sadie and Katya work on the homework together. All right, but they're not doing the same problems. Suppose Sadie does the problems on one page and Katya does the problems on another page. So their goal is to finish the homework and look at each other's work. So they don't go over the same problems. All right. So what part of the homework will both girls complete in A, 10 minutes, B, 20 minutes. So if we think about it, Sadie will have completed 10/40ths of the homework, and Katya will have completed 10/30ths of the homework. And if we want to see what part of the homework was completed altogether, we would add the two. And that would be our answer. In 20 minutes, Sadie would have completed 20 over 40ths, so half the homework. And Katya will have completed 20 out of 30, and we would add those two. And that would be the part of the homework that was completed. But if they both work for X minutes, we can represent the part of the homework completed by both girls as X over 40 and X over 30. And to see what part of the homework is completed, we would add these two. And the homework is completed. Well, if we go back to the do now, the work is completed when the part of the job or work done is 1. For instance, in the do now, we saw that Katya would have completed her homework after 30 minutes since her rate was 1 out of 30. But if we multiply 30 times 1 out of 30, we get 1. So if we wanted to solve for this equation, we could say x over 40 plus x over 30, right? This is the part of the job done by both girls after X minutes would be 1. So do you think, before we solve that, do you think the answer would be a number between 30 and 40? A number that's less than 30? Or a number that's more than 40? If both girls work on the homework the same time using their individual rates. Well, let's see. So this is a fractional equation, and we multiply both sides by the least common denominator, which in this case is 120. So let's multiply both sides by 120. Oops, wrong marker. 120 and 120. So we have x over 40 plus x over 30 equals 1 times 120 using the multiplication property of equality because we do have an equation. So we distribute on the side that has addition in the parentheses, and things divide through, so we get 3x plus 4x equals 120. 7x equals 120, and x is 120 divided by 7, which if we divide, we get 1, and let's see, and we get 17 and 1/7 minutes. Notice that this number is significantly less than 30 minutes. And the girls would save a lot of time if they worked together. So this is why when we work on something around the house or whatever job it may be, painting a room, it's always good to have someone helping you because we do save a lot of time. Okay, so let's take a look at some word problems that we have. Okay, this is problem 1 on your worksheet. So let's just write problem 1 here. So Alvin can complete his math homework in 12 minutes. Brian can complete his math homework in 18 minutes. How long would it take Alvin and Brian to complete the math homework when they work together? So in these problems, it's always a good idea to organize the information. So we have Alvin and we have Brian. And let's write down the formula on top of the chart. Rate times time is equal to the part of the work done. So the first thing we have to figure out is what is Alvin's rate? Well, it takes Alvin 12 minutes to complete his homework by himself, so his rate is 1/12. It takes Brian 18 minutes to complete the homework by himself, so his rate is 1/18. So how long will it take Brian to complete the math homework when they work together? Well, that's what we don't know. So we'll call that X. And X is the same time for both Alvin and Brian. So the part that Alvin completes is X/12, and the part that Brian completes is X/18. So let's write the key. Let X equal the time each student works together, and this is in minutes. We should write down that this is in minutes because the time could be in hours. And our equation is X/12 plus X/18 is equal to 1. And I'll leave the solving part. I'll leave the algebra part to you. Okay, but that's how we would set up the problem. Let's take a look at another one. This is number 5 on your worksheet. Last year, Sophie painted her room in 3 hours. This year, Elizabeth and Sophie were able to paint the room together in 2 hours. How long would it take Elizabeth to paint the room working alone? So it's a good idea to organize the information in a chart to see what is missing and what X should represent. So we have the rate times time equals part of the work done. So last year, Sophie painted her room in 3 hours, implying it takes her 3 hours to paint the room herself, which is her rate of 1/3. This year, Elizabeth and Sophie were able to paint the room together in 2 hours. So they each worked 2 hours, Sophie with the same rate. We have to see how long it takes Elizabeth to paint the room working alone. That would be our variable. Let X equal the number of minutes it takes Elizabeth to paint the room herself. So if we don't know how long it takes Elizabeth to paint the room herself, and we call it X, her rate is 1/X. So this last column can be completed. 2/3 is a part of the work done by Sophie. 2/X is the part of the work done by Elizabeth. And the equation would be 2/3 plus 2/X. And because we want them to complete painting the room would be 1. Now we have a rational equation, so we multiply both sides by 3x, which is the least common denominator here in this rational equation. And we have 2 over 3 plus 2 over x equals 3x times 1. We distribute on the side with addition, and we get the 3's divide through, we get 2x. The x's divide through, we get 3 times 2. And this gives us 3x. And solving, we get x equals 6. We could also subtract 2/3 on each side and get 2 over x equals 2/3. Equals 1/3. And when we cross multiply, we get x equals 6. But whichever way we do it, our answer is it takes Elizabeth 6 hours to paint the room herself. Now let's take a look at another one. All right, this problem is number 14 on your sheet. Together, Larry and Mo require 4 hours and 48 minutes to pave a driveway. Alone, Larry would require 4 more hours than Mo. How long would it take Mo to do the job alone? So let's just make a little chart again. Larry and Mo. We've got rate, time, and part of job done. Now, I'd like you to try to fill in the chart yourself and come up with a key and an equation. All right. So now we're going to express this in hours. So together, Larry and Mo can pave the driveway in 4 hours and 48 minutes. So let's see. 48 minutes in hours. Well, we can divide by 12. We get 4/5, I believe. So it takes each 4 and 4/5 hours to mow the lawn together, or to pave the driveway together. Alone, Larry would require 4 hours more than Mo. Okay, so this is a little different. We do not know Larry's rate and Mo's rate, but we have a relationship between their rates. So let's see. We could let X represent the number of hours it takes Mo to pave the driveway himself. And X plus 4 would represent the number of hours it takes Larry to pave the driveway himself. And that's because it says, alone, Larry would require 4 more hours than Mo. So their respective rates would be 1 over X and 1 over X plus 4. So the part of the work done by Larry would be 4 and 4/5 divided by X plus 4. And the part of the work done by Mo would be 4 and 4/5 over X. So let's change 4 and 4/5 into, actually we'll leave it. So the equation would be 4 and 4/5 over X plus 4 plus 4 and 4/5 over X is equal to 1. Now let's change 4 and 4/5 to a mixed number, an improper fraction, I should say, and that would be 24/5. So we have 24/5 over X plus 4 plus 24/5 over X equals 1. Here we have a rational equation The least common denominator is x times x plus 4. So let's multiply both sides by that. And this is understood to be over 1. So we recopy it. Okay, and when we distribute on the side with the addition, the x plus 4's divide through, so we get 24x over 5. And the x divides through, so we get 24 over 5 times x plus 4, which really belongs in the numerator here, is equal to x times x plus 4. Now, we can multiply both sides by 5 to make this, to clear all denominators. So if we multiply both sides by 5, we should get, so we get 24x plus 24 times x plus 4 equals 5x times x plus 4. Now I'd like you to solve this equation yourselves. So when we solve this equation, we end up with a quadratic. And the quadratic equation comes out to be 0 equals 5x squared minus 28x minus 96. It turns out to be factorable. If you use the quadratic formula, you would get the same answer. The factors are 5x plus 12 and x minus 8. Notice that the inner and outer terms, you get 12x minus 40x, which gives us a negative 28x. So the two possible answers when we set each factor to 0, x equals negative 12 fifths, which we reject since we know that time cannot be negative. So the answer is x equals 8. So the final answer to the question would be that it would take Mo 8 hours to do the work himself. Namely, the work was to pave the driveway. And it takes Larry 4 more hours. So that would be 12 hours to do the work himself or pave the driveway. So notice that these problems can become more difficult to solve. All right, let's take a look at one more. Okay, so number 9 tells us that Herbie and Andre working together can complete a project in 12 hours. Okay, so we have their time there. Andre requires 18 hours to do this project alone. Herbie and Andre start the project together. After they worked for 4 hours, Herbie had to leave for his music lesson. How many hours will Andre require to finish the project alone? So again, let's make a little chart here. And it seems like we're being asked a lot of questions, but let's take it a step at a time. So this is the rate times time is equal to part of the work done. Okay, so we begin. Herbie and Andre working together can complete their project in 12 hours. So that's 12 for each. Andre requires 18 hours to do the project alone. So the only thing missing here in order to find... Oh, I'm sorry, that's Andre's rate. So the only thing that's missing here is to get Herbie's rate. So let's call that 1 over x. I mean, that seems to be important in the second part of the problem. So we'll have 12 over x for the part done by Herbie and 12 over 18 for the part done by Andre. And the first part would say let x equal the number of hours it takes Herbie to do the project alone. So Our first equation can be 12 over x plus 12 over 18 is equal to 1. Let's try to do this as quickly as possible. So I could rewrite the 12 over 18 as 2 over 3, subtract the 2/3 and get 1/3. And when we cross multiply, we see that it takes Herbie 36 hours to do the project himself. Now that we know how long it takes Herbie to do the project himself, which is really very important for this problem, we have a new situation. After they work for 4 hours, okay, meaning that they worked together on this project for 4 hours, Herbie had to leave for his music lesson. So how many hours will it take Andre to finish the project alone? So let's make now a new table. So we know that Andre could do the work by himself, finish the project in 18 hours. So his rate is still 1/18. We found out it takes Herbie 36 hours to complete the project. So his rate is 1 over 36. It did say now in the third line or fourth line, after they worked they start working on the project together, and after they worked for 4 hours, Herbie had to stop and go to his music lesson. So Herbie just worked for 4 hours, but Andre kept on working. So Andre worked 4 and more hours until the project was done. So let X here represent the number of hours it takes Andre to finish the project himself. So that means that the part of the project that Herbie contributed to was 4 out of 36, or 1/9. And the part that Andre will contribute is 4 plus x over 18. So we add those to complete the work done, or complete the project, and we get this equation. 1 over 9 plus 4 plus x over 18 equals 1. Now, the various ways to solve it: we could subtract 1/9 on each side and get 8/9. Cross multiply, which is really multiplying both sides by 18. Okay, we could divide each side by 9 here. So we get 4 plus x equals 36. And no, actually it's 2 times 8. There's a typo here. This should be 2 times 8. So this should be 16. That's more like it. 16. So x is 12. So it would have taken Andre 12 more hours. Another way to solve this, which is equivalent, is the traditional way, as we saw in the few videos ago. We multiply both sides by the least common denominator, which is 18. And we get 2 plus, okay, now the 18s divide through because we distribute on this side. So we get 4 plus x equals 18. And we end up with x is equal to 12 again. So whichever way we do it, Andre needs 12 more hours to finish the project. All right, let's try one more. Okay, so let's take a look at this last problem, number 11. Bill and Tom painted a fence in 8 hours working together. Okay, so that immediately gives us the time. Last year, Tom painted the fence by himself. The year before, Bill painted it by himself, but took 12 hours less than Tom took. How long did Bill and Tom take when each was painting alone? All right, so let's start with the chart now. Bill and Tom. And we'll break it up into pieces. Rate times time equals part of the work done. Okay, now they worked together for 8 hours, so that's how long it would take them to work and paint the fence together. But here it's implied that we don't know the rate, but they did say that when Bill painted it by himself, it took him 12 hours less than Tom. So we could say let x equal the time, the number of hours it takes Tom to paint the fence himself. And let x minus 12 equal the number of hours it takes Bill to paint the fence himself, which would make their rates 1 over x and 1 over x minus 12. Okay, so that would give us the part of the work done, which would be 8 over x minus 12 for Bill and 8 over x for Tom. And to complete working on the fence, to solve for x, we add these two fractions together, and we always make it equal to 1, since part of the work done has to be completed, and that's 1. Now we proceed to solve algebraically, and we can multiply both sides by the least common denominator, which is x times x minus 12. Okay, so I have 8 over x minus 12 plus 8 over x equals 1 times this. Okay, so when we distribute on this side, we get 8x plus 8 times x minus 12 equals x times x minus 12. All right, so that, and again, the whole idea is to clear all the denominators. Now we distribute and solve the resulting quadratic equation. So let's do that quickly. We get 8x plus 8x minus 96 equals x squared minus 12x. We have 16x minus 96 equals x squared minus 12x. So we subtract the 16x on each side, we get minus 28x, and we add 96 on each side, and we get this quadratic equation. So we have to find two factors of 96 that add up to negative 28. And I guess they would both have to be negative. And let's see what that would be. I believe it's negative 24 and 4. So when we set each factor to 0, let's go on to the next page. We get two possible answers. X could be 24 or X can be 4. Now, let's take a look at the 24. If X was 24, then it takes Tom 24 hours to paint the fence himself. And it would take Bill, 12 hours less to paint the fence himself. If X were 4, then it would take Tom 4 hours, but 4 minus 12 is a negative number, so we reject this answer. This is impossible. So that concludes that work problem. So notice that in a work problem, to summarize, the key always represents one of two things. Either the time it takes to finish the work himself or herself alone, or it could represent the time that the two work together. Now, we have to be careful with the time, because one person can begin and stop and the other person continues, or they work together. So we have to consider this one very, very carefully. But in every work problem, these are the two in the key. One of these two is in the key. And with the equation always talks about the part of the work done by one person plus the part of the work done by the second person equals the total work done, which is 1. Okay, that takes care of work problems. Have a nice day, everyone.